Hello everyone, in this recording we're going to discuss how we can use the interactivity which we defined in the previous notes to build some visualizations from D3. So we're going to recreate the visualization that we made in Shiny earlier. It's the Rotten Tomatoes versus IMDb ratings dataset. Before we had done different kinds of brush inputs, different kinds of click inputs. Now we're going to have similar kinds of input, but I think you're going to find it's quite a bit richer. We're going to have a lot more flexibility defining interactivity in D3 compared to Shiny. So before we get into the interactivity, let's just look at how to make the scatter plot. So this is what the static scatter plot looks like. There's no interactivity in this plot. To generate this, we first need to bind all the circles. So here I defined a circles group, and I'm using the usual D3 enter pattern. So data is a long array. Each element in this array corresponds to one movie. That movie has a whole bunch of attributes. So it has a title attribute, has a rating for each type of rating, has a genre. I'm appending each of those movies and creating a circle associated with each one of them. And I've defined a whole bunch of attributes. CX and CY are the location. The location are defined by scales, just like in the Gapminder dataset. I'm also changing the color depending on the genre. And which color I use depends on the scale for this fill color scale. Okay. This class I'm setting to distinguish between points that are selected by the user and points which are just in the background. So when it's class plain, these are going to be just points in the background. I don't want to highlight them. I've defined a whole bunch of attributes associated with class plain in the CSS file associated with this scatter plot. Okay, so that's just going to create all the circles in the scatter plot. How do you get these nice kind of axes? I'm using D3 axis bottom and axis left. So I'd already defined the scales. That's what's figuring out what the numbers should go. Right? And there's some G element which I defined as empty at the beginning, and when I call this axis object on that empty G element, is going to populate it with all the text, all the lines that define this particular axis scale. Okay, so far we've made it a static scatter plot. What are certain kinds of interactivity that might be interesting? So one very natural kind of interactivity is to create a tooltip. So this is like a tooltip, right? Every time I mouse over a circle, I'm giving the title of that movie. So why would you want to do something like this? Conceptually, this is implementing the principle called details on demand in the visualization literature. What this means is when you initially show a visualization, there's a lot of extra information we could be showing. Like I could imagine showing all the names of all the movies on the scatter plot at the very beginning, but it would be impossible to read anything. The names for all these different points would be overlapping and you wouldn't be able to know what is what. That said, not being able to show the names at all could be pretty dissatisfying for the user. Right? You might want to know, what is this movie, like these with the really high ratings, right? Or what are the ones which have really high Rotten Tomatoes ratings, but really, really low IMDb? Right? So by implementing a tooltip, we're providing those details on demand by the user. Okay, how do we implement this? So the first thing we need to do is we need to listen for any kind of interaction the user makes with any of these points. That's just like what we did in the previous notes. We just need to bind this mouse over listener, and every time the mouse over, anytime any point is moused over, then I need to call some function. This is a function that I've written. I'll show you the code below. And what it's taking as argument is taking the event associated with the mouse over, and it's taking some attributes of the underlying object. Right? The event includes things like the location of the mouse, but it doesn't actually say anything about the data that's bound to that HTML element. If I also want to access the data associated with that element, I need to pass in this second D argument. Okay, so that is the first step in interactivity, is just noticing when there's any interaction. The second step is once you notice that there's an interaction, you need to update the visualization to reflect that interaction. So what needs to change in order to reflect the mouse over so that we have a tooltip the two things need to happen. First, we need to change the text on the tooltip. Then we need to move it to where the mouse is. So let's break this down into a few parts. This is what that mouse over function, which I'm calling every time the circle is mouse over, is. Here I'm getting the location of the mouse. Remember, d3.pointer gets the location of the event. I'm taking some empty div element that I had before. I defined it on the main HTML. I gave it an ID called tooltip. And what this first adder is doing is it's moving that tooltip to the location of the mouse. That's what this translation does, and I'm just substituting the location from my d3.pointer. So that's moving my tooltip to where it needs to be. Then I'm putting in some text. So .text title is going to fill in that div with the title of the movie. So every time I mouse over, I'm getting the title, and that's why I actually needed this second argument. If I didn't have the second argument, I wouldn't be able to get the title to fill in my tooltip. Okay, so that is the main thing that's giving us the titles. This last part is converting the class of the circle from class plain to class highlighted. If you notice, if you look carefully, the circles get bigger, right? They're not just adding text. So how do I know to make the circles bigger? I'm knowing that because I'm changing the class, and I have properties of class highlighted making the radius larger. Okay, so that's how to implement a tooltip. You might imagine that you want to show more than just the name, right? Here I'm showing a whole bunch of attributes, right? So the release date, the genre, and how much gross it had, right? So this is the same kind of principle, except instead of moving the div element around, I'm accessing these HTML tags that define the table, and I'm just substituting that HTML tag with the text associated with the data object. So these are the names for those table elements, and I'm just substituting properties of the object. Okay, so that is different kinds of hover events. Now let's think about click events. So what I'm creating here, the same kind of plot from before, no hover this time, but when I click on the legend, it's changing the size of the circles. Right? They don't disappear, but they get really, really small. Right? So this is going to be helpful if you want to say, compare a couple of genres with one another. So these are all the comedy, these are all the drama. You can kind of compare where do they lie on the rating distribution. Notice this is a kind of interactivity that we would never be able to do in Shiny. Right? If we wanted to do this sort of thing, we would have a drop down. We wouldn't be able to create these sort of scented widgets. So how do we implement something like this? Right? We're going to have to be able to recognize when the user has clicked on the genre, and we're going to need to update all the points according to what are the currently selected genres. Right. So here, I'm defining a click event on all these rectangles. So these legend cells are exactly the class that I've given to all the legend elements. Right. And then when I click on it, I'm calling this toggle selection function. What is toggle selection doing? So I've defined a global object called selected, and it's having all the genres that are currently selected by the user. At the beginning, it's just showing all genres. When I click on a certain cell, it's going to look at what that genre is. If it's contained among the selected genres right now, if it's contained, then I'm going to remove it. If I search for it and I don't see the currently clicked cell, right, that means it's not one of the selected genres. Right? That would be like if I'm clicking one of these light colored ones, right? So at the beginning, it's not in the selected array. And if I'm clicking it, that means I actually want it in the selected array, so I'm going to push it. I'm going to push the name of that genre into the array of currently selected movies. Once I have updated my selection, I can change my visualization. And that's what update view is doing. How does the visualization change? I'm changing the opacity and the radius of all the points. So if the genre is among the selected genres, I'm making it really big, otherwise I'm making it kind of small. Or that's the opacity, and the radius, it's either radius 2 or radius 1. Okay, and I slowed it down just by using a transition. If I had not included the transition, the points would change in color and size immediately. Okay, so that's the main kind of change. I also actually was changing the opacity of the rectangles, right? If you notice here, it's not just recognizing that I clicked and not doing anything. When I click it, the cells are getting more opaque, right? Or transparent. Right? The way I'm doing that is I'm just looking at whether it's one of the selected genres. If the genre has been selected, I'm making it opaque and not transparent. If it's been deselected, then I'm making it transparent. And I do that for both the rectangle and the text. Okay, so that is different kinds of hover inputs, different kinds of click inputs that you can use. It's just a basic scatter plot, but then it's already more than we could ever do in Shiny. And these sort of principles are going to apply to all sorts of figures.